This is another example of an exponential growth model dealing with population. This is the population in 1970. This is the population of the United States, 203 million. And in 1980, the census had the population at 226 million. We're going to assume that the population growth is exponential. And what I'd like to show you is what happens when we can't obviously see what the initial value is. What I usually like to do is I'd like to get two ordered pairs from the information. So from this information, I get that in 1970 the population is 203. What I do is I initial this out. I let this be the initial population, and then therefore in 1980 the population 10 is 226 million. Our model is this model. It should be very familiar to you. It's one of the models that we use when we were doing continuous compound interest, and the idea behind this is that populations are growing continuously. And now I can substitute things that I know. First, I need to find the initial population, and I need to find the rate at which the population is growing. There I need two ordered pairs, and these are the ordered pairs I'm going to do. First, I'm going to substitute in the initial value, and we get 203. So right now we have population is 203 e to the RT, and now I need to use the other pair, 10 to 26, to determine the rate at which it's growing. So 226 goes in for the population and 10 goes in for time. And then we need to solve this equation for R. First we'll divide 226 divided by 3, and then we'll take the natural log, and we get R to be approximately 0.001336. Now, I took this out to as many places as I can. The more places you take it out to, the more accurate your model is going to be. So for our purposes, this is good enough. You should understand how I calculated R. If there's any questions, see me about it. And what we now get out of this is this following model. This is the model that we're going to use that models the population. First I want to show you first where we put that. We put the R value here. Notice how I put T minus 1970 in parentheses. When I put 1970 in, that's going to be my initial population. So 1970 minus 1970 is 0, and so e to the 0 is 1, and we get to 203. You should also see that when we put 1980 in, we get very close to 226, and that's what we're going to use. Now we have a model that can determine the population in the future, and we can determine, if we know a population, we can pretty much figure out the time. Once we have the equation, all we need to know is what given a t value, what's the population, or given a population, we can figure out approximately what time that was. And that's basically it.